Hello, hello, and welcome back to the Fabric of Industry podcast, episode 4, Quarrying and Petroleum. I'm your host, Adam Grange. This will be the final installment in the foundational episodes for the primary sector and its main industries. Quarrying could have better fit into the episode on mining, the previous episode, but with that last episode running over an hour, I decided to save it for this one. Hopefully this one will be around the same length or shorter because of that. However, discussion of crude oil will take up the majority of this episode, and then we'll discuss a little bit about natural gas near the end since it ties into petroleum, to oil. Prerequisites include the first half of episode 1, just like the previous episodes. That episode 1 is what is the primary sector, and at least to get a better understanding on quarrying, I would recommend listening to episode 3 on mining as well. In fact, I would recommend listening to episodes 1 through 3 to get the full scope for understanding what the industries are in the primary sector. But most of the information in those won't be necessary to understand this episode. Alright, let's begin. So first I will discuss quarrying. If you haven't listened to episode 3 on mining, some of this may not make sense because I won't be explaining types of excavation, equipment, and minerals here. Quarrying is a form of surface mining, typically open pit, that extracts dimension stone or construction aggregate. So I will start by explaining each of these. Dimension stone is perhaps what most people think of when they consider what is excavated at a quarry. Dimension stone itself is the end product for the primary sector activity before being moved for further processing in the secondary sector. It is stone or rock that is finished into a specific size and sometimes a specific shape, though it is usually cubical or cuboidal, which I believe is the adjective for a rectangular prism. Construction aggregate, which I will now be referring to as just aggregate, is natural particulate material used in construction. A lot of various types of rock that are excavated in quarries form massive deposits, which just means the deposit lacks any other internal structures, so the deposit is contiguous throughout of just the one material. If you listen to the episode on mining, then you will understand this next bit a little better. A dimension stone is used widely in construction for structural or decorative purposes. These are rocks that are mostly silicates and are congregated of multiple minerals. Granite is an igneous rock, usually composed of quartz, which is a silicate, alkali feldspar, and plagioclase feldspar. I didn't break down the specific types of each mineral class last episode, and I'm also not going to do it here because the science of specific mineral classification isn't necessary for understanding mining and quarrying. Perhaps I'll do an episode on that later before making construction episodes and episodes along those lines, so that we can fully understand why certain materials are used for certain applications. Anyway, the next dimension stone quarried is limestone. I mean, this isn't in a line, but just the next one we're talking about is limestone. And limestone is a carbonate material that forms as a sedimentary rock. It is mostly calcite and aragonite, which are both, of course, carbonates. Travertine is a commonly mined type of limestone which deposits around mineral hot springs and therefore has different physical properties than limestone due to the heating and pressure. Marble is a metamorphic rock mostly composed of the carbonates calcite, and dolomite. Sandstone is perhaps the most classic sedimentary rock and is small sand-sized silicate particles that remain compacted together due to some other mineral in its composition, kind of like a glue. It is a quartz-based rock, which is a silicate, but can be of feldspar as well. Quartzite is a quartz sandstone that has become a metamorphic rock instead of it's gone from being sedimentary into a metamorphic rock. Slate is also a metamorphic rock and contains quartz, but also usually contains either muscovite or elite, both of which are silicates. Slate is that classic grayish rock that shears off the face of the rock face in thin sheets. These are the major types of dimension stone, but further minor types also exist. I mentioned gypsum last episode, but It is a sulfate, and it's a very soft mineral. One kind of gypsum is called alabaster, and is perhaps another quarried stone you may have heard of. Talc is a general clay mineral that is soft and is also a silicate, or more specifically, a magnesium silicate, which has become hydrated. Again, the specifics of that doesn't really matter too much. Soapstone is a commonly quarried type of talc and is actually a metamorphic rock. You have also probably heard of asbestos. This is a fibrous silicate mineral, which is commonly quarried from serpentine minerals. Yes, asbestos is still quarried quite a bit because it does have various uses. It just isn't generally used in housing and buildings anymore because of that fibrous structure it has. The way it affects the lungs, it's carcinogenic in humans. But it does still have several other uses. Aggregate is the next major type of quarry, and it contains very common materials. I hopefully don't have to explain too much. Sand, which is generally silicon dioxide when it is quarried. Gravel, which is kind of aggregated loose rock fragments, and just crushed stone, various types of crushed stone, which is any type of suitable dimension stone that is crushed into a desired size. Usually about the same size as gravel, but the fragments are more angular and sharper than typical rounded gravel chunks, since gravel is naturally produced, usually through erosion processes. These are the most commonly quarried. These are most commonly quarried for use in composite materials, which are generally concrete or asphalt. Since quarrying is relatively similar to mining, I won't develop an entire exercise in looking at the differences between various stages of development and their effects on the industry. Instead, I'll just save that for the crude oil industry, the petroleum industry. But I will list some facts regarding global quarrying. In the United States, there is a granite quarry known as The Rock in Mount Airy, North Carolina. There exists over 60 acres of exposed rock, with the entire deposit of granite stretching 7 miles long to about 1.25 miles wide, and it's over 1.5 miles deep. It consists of mostly beautiful white granite. That might be the classic sort of granite that you'd picture, maybe a red one. Moving to aggregate, since granite is excavated as dimension stone most often. In Canada, the Setchelt Sand and Gravel Mine produces over 4 million tons of gravel, sand, and crushed stone a year. The aggregate from this quarry is used mostly for concrete production, which will be the focus of a very fun episode in the future. Or maybe multiple episodes. Concrete's kind of actually complicated. Anyway, the quarry stretches over 450 hectares. A very classic example we all may be aware of is Italian Carrara marble, which is a famous marble used in Michelangelo's David and Giovanni Strauss's The Veiled Virgin statues. You will probably know these if you look them up, if you can't picture them in your head right away. The Yangshan Quarry in China has existed for over 600 years, I believe since the Ming Dynasty era in the 1400s. I don't believe it produces limestone anymore, and I think it is a protected site, nationally protected site. But regardless, China is by far the largest producer of limestone. As for underdeveloped countries, it isn't actually typical of any of these countries to produce large quantities of dimension stone or aggregate. My theory on this is it isn't very economically viable for poor countries to attempt to mine stone on an industrial scale, since it is very expensive, and stone is a relatively cheap commodity as compared to more precious metals and rare earth metals and things like that, which are more commonly mined in underdeveloped countries. Rather large quantities of those rare and expensive minerals and materials, such as uranium, gold, and especially diamonds. This is a point that could definitely be argued, and there are several other factors for that, but for this discussion, and since this is an episode on primary sector activity and not specific theories on economic development, we'll save that for a potential later discussion. Obviously, quarrying is going to have similar environmental effects and ethical issues as open pit mining does, since that is essentially what it is. The paradox here is that stone is a required resource for construction, but the communities made from the materials that are located close to quarries experience the most severe impacts. Aside from that, when quarries are abandoned, they are rarely ever refilled or terraformed, just as any open pit mine. It's like a limestone quarry, for example. Let's say this limestone quarry is located in a developing country somewhere, and there's a city or a village located in close proximity, probably a village. The limestone provides the country and the local community with resources that include, limestone itself, money and jobs generated through the export of limestone, and other trace non-gang minerals or material alongside the limestone deposit. If you remember from last episode, a gang mineral is a mineral in a deposit that isn't desired for the specific industry, and even if it has industrial applications, let's say apatite in an iron vein, which is used as a fertilizer, it is generally considered industrially useless for whatever is focused on being extracted, which would be the iron. Anyway, since we're talking about limestone, this of course does not mean quarrying is all good. Quarries take up vast amounts of space and remove other resources for nearby people or other business activities, such as trees, other foliage, arable land for farming would be a big one. They may end up encroaching on the nearby village, and blasting operations and other equipment produce large quantities of dust, which can contribute to air pollution, and the noise pollution may be a factor as well. Waste products, or tailings as they're called, leaking into local water supplies have obvious impacts on quality of life. But, does the village just pack up and leave even though its people have potentially been there much longer than the quarry? Or does the quarry cease operation and forgo the economic development it contributes to? So, like I said, a bit of a paradox there. Anyway, I think this is enough on quarrying, as again, a lot of the foundational information for the industry is quite similar to mining. Petroleum, or crude oil, is a liquid that occurs naturally in rock. Petroleum is thought to be formed mostly from the compression and heating of plankton, which are microscopic organisms that are not truly capable of moving against a current either in water or in air. They're usually aquatic organisms. It is a highly complex organic mixture, petroleum, of mostly hydrocarbons and some other trace organic compounds and metals. A hydrocarbon is an organic compound that is made solely of hydrogen and carbon, hence the name. And they are the focus of the petroleum industry. Hydrocarbons themselves can be solid, liquid, or gas, but occur in petroleum before processing as liquids. 4 different types occur in petroleum, and they are alkanes, naphthenes, or cycloalkanes, aromatics, and asphaltics, in descending order of composition of petroleum by weight. I will probably do a hydrocarbon episode when I start doing some chemistry episodes so we can better understand the properties of materials and why they're used in certain industries, just like I was talking about mineral composition and things like that earlier. And because the classification is quite a bit more complex than minerals. The petroleum, once extracted, is processed usually by distillation, but again, I will probably I would definitely do a series of episodes on oil processing because it is just such a vast topic. We are all probably most aware of processed petroleum as fuel, such as gasoline or diesel, or perhaps plastics, but there are a truly staggering range of other products petroleum can produce. Anyway, petroleum is extracted primarily through drilling, either offshore or on an oil field. Exploring this will be our focus for the rest of the episode, and I will talk a little bit about the fracking of oil sands in shale, and natural gas as well. We'll start with some of the terms here. An oil deposit is a deposit of the liquid petroleum inside of a rock formation. The reservoir is the entire chamber the deposit is enclosed in, and includes the air and other petroleum gases that exist within the reservoir, as well as the petroleum itself. So it's liquid and gas in the reservoir, while the deposit is just the liquid petroleum. A well is the opening into the deposit and the reservoir once a borehole has been drilled into it. A borehole is just a hole drilled into the earth, And in the oil industry, it's performed by a drilling rig. A drilling rig or oil rig is a type of drill that drills a well for the extraction of oil. They range quite a bit in size, from small augers that are capable of being operated by one person or a small group of people to large towers or structures. Drilling rigs placed into a structure are used almost ubiquitously in the petroleum industry because they are capable of drilling deep holes into the earth to actually reach an oil deposit. The borehole is drilled by 30-foot steel pipe lengths with a drill. Well, this is in the United States. Other places may be different than about 30 feet, but they're about the same length. And this pipe will have a drill bit affixed to the end. And once that section of pipe is fully descended into the earth, a new section is affixed on top without the drill bit until the oil reservoir is reached. That's just repeated over and over again until the oil reservoir is reached. A mud mixture is pumped down the drill pipe while it's descending into the earth for lubrication and to move the rock that is drilled up to the surface of the pipe. So they pump it in to the pipe, it goes down the pipe, and then it grabs any of the solid rock and dirt that the drill is drilling out of the way to make the hole, and then the mud mixture floats back to the surface, carrying all that rock back to the surface. Holes are then drilled into the base of the well once the deposit is reached to allow oil to flow upwards through the pipe, through the borehole. An arrangement of valves, which is referred to as a Christmas tree in the industry, is placed at the top of the bore, and this is to regulate the flow of the oil out of the well. Typically, a Christmas tree is constructed of 4 to 5 valves in a crucifix pattern, hence the name. But the exact configurations aren't too important unless you actually work in the oil industry. Just know that they are very important because of what I am about to talk about. Pumping units are then connected to the Christmas tree at the top of the well to create pressure so the oil may rise to the surface. Commonly, pump jacks are used in oil fields and offshore oil rigs, though the ones on oil fields may be a bit more familiar in your mind. You may have seen images of these, and they sort of look like a horse dipping its head into the ground and then raising again. These are actually reciprocating piston pumps, they consist of a beam with a counterweight attached to the opposite side from the actual pump side, and then the counterweight is attached to a motor. The pump drops a circular motor. The pump drops a rod into the well that has 2 valves affixed to the end of it. The pressure difference that's created when the pump is in a downstroke will open the bottom valve and close the top valve. These valves are called check valves. They're commonly cone check valves, and they will only open when positive pressure pushes it open. So when it's in the downstroke, because once the valve is open, then fluid may flow into the rod. So in the downstroke, the positive pressure is being created that opens the bottom valve because the valves are being pushed down, the pump is being pushed down, and so the bottom valve opens, but this will of course close the top valve. So oil from the reservoir can flow into the rod, but it won't continue flowing upwards. It'll just flow into the little section of the pipe where the valves are, the section of the rod where the valves are, and then on the upstroke, when the pump is moving upwards, the bottom valve will close and the top valve will open, allowing the fluid to flow then all the way to the surface. These pumps only operate when the pressure created by the reservoir itself is insufficient for the fluid to flow to the surface, which is what I'll talk about in a second. In terms of the 3 levels of oil recovery from a well, they're typically divided into 3 separate levels, which are primary, secondary, and enhanced, or it's also called tertiary, which they each have a few different methods. Primary recovery is the natural process from a pressure difference between the surface where the Christmas tree is and the pressure inside the oil deposit itself, or the reservoir itself. There are several ways nature allows oil to flow to the surface by creating this pressure difference. It could be just natural water flowing into the deposit, or expansion of gas inside the reservoir, or gravity. You can expect to recover between 5 to 15% roughly of the deposit from primary recovery. Secondary recovery occurs when the pressure difference is flipped as the pressure inside the well declines. There are 3 main techniques used for secondary recovery. aside from the actual pumping unit, the pump jack creating pressure itself, because that's not technically one of these types of recovery. Anyway, once the pressure difference inside the well is lower than on the surface, then the oil will no longer continue to naturally rise to the surface, so artificial pressure has to be created. And this is created through water injection, gas reinjection, or gas lift. Water injection, or water flooding as it's sometimes called, is simply injecting water through another borehole drilled into the reservoir to increase the pressure again, because now there's more stuff taking up the limited space inside the reservoir, the water's taking up more space, and so it creates pressure. And so this can drive the oil towards the well. This works because petroleum, well, the hydrocarbons that it consists of are actually hydrophobic, which means they are therefore repelled by the water and do not mix with it. Now, you can pour some olive oil or some other oil into a glass of water to see this effect. Gas reinjection is exactly how it sounds. The gas that was released from the inside of the reservoir is reinjected into the reservoir to increase the pressure again. And then gas lift is typically carbon dioxide or some other inert gas, which just means it won't react with anything inside of the reservoir. The gas is used to increase the pressure and, well, again, lift the oil into the well. You can expect about 30% recovery from secondary recovery, which means you're probably between 35 to 45% of the oil extracted, which is a respectable number, but sometimes you want to delve into enhanced or tertiary recovery. And this is a separate category than secondary because what it does is it increases the mobility of the oil itself instead of just increasing the pressure in the reservoir. They aren't always used on the deposit itself. Anyway, they differ from secondary because secondary methods are sort of the direct injection of a fluid, either a liquid or a gas, and that is done to increase the pressure of the reservoir, like I said. But enhanced methods utilize heat or detergents to reduce the viscosity of the oil, which the viscosity is a liquid's resistance to flowing. And so that increases the mobility of the oil instead of increasing the pressure. So that allows the oil to flow more readily. Steam reinjection, or steam injection, sorry, is very common. And it is done not to increase the pressure, again, but to increase the heat of the oil so its viscosity is reduced. And therefore it can flow into the well easier. This will also increase pressure because you're, again, basically putting more stuff into the reservoir, so there's more stuff in the reservoir that increases the pressure. So that's a bit of a byproduct of that. Detergents, or more generally, they're called surfactants, are injected to decrease surface tension between the water and the oil in the reservoir, which in turn increases the mobility of the oil. Tertiary recovery can allow for an additional 5 to 15% of oil recovered, bringing our total to somewhere between 40 on the low end and 60 on the high end, which are pretty good returns on investment, especially because of the cost of oil. The oil left over in a deposit once it has become too economically unviable to continue extracting it is called residual oil. The mixture extracted from the well is typically about 90% water and about 10% oil. In an oil field, so on land, all of the wells feed into pipes and then feed into a main line. The fluid must go through a gas removal process to remove carbon dioxide, hydrogen sulfide, and natural gas. The latter two of which are used for other industrial applications. These are known as petroleum gases or reservoir gases. Since gases are lighter than liquid, they flow to the top of a tank naturally and are extracted away from the petroleum liquid. Natural gas is useful in its mostly native state, but hydrogen sulfide can be further processed on site to produce sulfur. Usually the oil field will use the natural gas to power the on-site equipment. Water separated from the crude oil in a separate process, which happens naturally, as I stated earlier, is heated with the natural gas to produce the steam for steam injection. Although typically an emulsion breaker is added to the oil-water mixture to separate the two more cleanly, since if you did pour the oil into a glass of water experiment, you would see that there are a lot of small bubbles of oil that are difficult to then extract from the water. It's not like a clean, like half and half break, right? The carbon dioxide separated from the reservoir fluid is also sometimes used for gas reinjection or gas lift most commonly. The crude oil, since it is now mostly the last thing left in the fluid, is brought to filter out sands and other small solid particles, so it is ready to be sold as the raw resource petroleum. Once the oil mixture is 98% or more pure crude oil, then it is packaged into barrels, which is the standard shipping container for petroleum, and it is 42 US gallons. A barrel of oil has risen from about $1 in the mid 40s to 68.79 as of market close while writing these notes. It has fluctuated between around 45 and 65 for the past 20 years, with a high of about $140 in 2008 during the global recession, and dipping harshly down to $18.84 in April 2020, which you can probably guess why. That didn't last long, but we will speak briefly about the types of crude oil in case I mention the types a certain country may produce. You may be thinking, wait, I thought it was all just oil, which is true, but depending on the mixture of hydrocarbons present, the weight may change. In addition, the sulfur and acid levels influence the type that is extracted. Weight of crude oil refers to whether it is light or heavy. You may have heard of light oil or heavy oil before. This is a range that is measured in API gravity, which is density compared to water. Essentially, if it is heavier, it sinks in water, and if it is lighter, it floats on water. And there is a breaking point in the middle at a measurement of 10 in which it sinks or floats. The heavier the oil, the lower the number. Heavy oil is more useful for producing things like asphalt, and light oil is more useful for producing things like gasoline. Sour or sweet oil refers to the sulfur content, in which higher sulfur content, generally around 1 to 2% of the mixture, is sour, and lower sulfur content, which is below 1%, is sweet. Oil that is more sour requires more on-site processing to remove the sulfur. The TAN count stands for the total acid number and refers to how corrosive oil is. Corrosivity is a measure of how aggressive an acid is and generally correlates with lower pH acids being more corrosive. For example, stomach acid is extremely corrosive, and which that's why it can pretty much dissolve anything we ingest, right? And it has a pH of around 2, with 1 being lowest on the scale. The reason the TAN count is important is because if there is a higher corrosivity of acids in the crude oil, then the pipes that carry it need to be reinforced with a more robust metal so the acids don't eat away at the pipe and dissolve it. The actual measurement used I don't think is important for us. Each region of the world produces different types of oil with variations in all of these measurements. And this is important because it can affect the export of a country on whether or not the global market requires more or less of their specific oil. Now let's get into the meat of the economics of the petroleum industry. The United States is the world leader in petroleum production at 13.4 million barrels per day in December of 2024. Saudi Arabia is second, with Russia coming in close third, both close to about 11 million barrels a day. Canada is actually fourth with 5.5 million, and China is fifth with 4.7 million. The Organization of the Petroleum Exporting Countries, or OPEC, as you may have heard it called, is the conglomeration of countries that are in cooperation for being the leading petroleum producing countries worldwide. There are currently 12 members, and they account for almost 40% of the world's petroleum production. Between these 12 countries, it's estimated that about 80% of the world's oil reserves are located in them, and 67% of that is located directly in Middle Eastern countries. Most of the high oil producing countries are relatively well developed, but once you get further down on the list, you have some OPEC countries with relatively low development, Algeria and Libya, and Nigeria is fairly low developmentally. The three countries we'll focus on for the ranges of developed, developing, and underdeveloped will be Norway, which produces about 2 million barrels a day, Iran, which produces about 4 million barrels a day, and Nigeria, which produces about 1.6 million barrels a day. Norway is currently the second most developed country in the world, tied with Switzerland at a Human Development Index of 0.970. As a quick aside, in our first episode, I mentioned that Switzerland was number 1, and so you can see how these rankings can change frequently, even for the most developed countries. But most countries stay around where they are. Anyway, Iran is a middle developing country in the Middle East with a current ranking of 75 and a Human Development Index of 0.799. Nigeria is an underdeveloped nation in West Africa with a current ranking of 164 and a Human Development Index of 0.560, and it has actually been dropping recently. Norway is a country in northern Europe, one of the Scandinavian countries. Currently, Norway is the 11th largest producer of petroleum. We'll talk about this a bit later, but just to mention it for now, I believe they are also the third largest exporter of natural gas, because the North Sea has vast reserves. Norway's petroleum and natural gas exports account for about 40% of the country's entire export value, which is about 17% of its total GDP, nominal GDP. So right off the bat, we can see that it isn't just underdeveloped countries that heavily rely on a certain resource for its economy. The difference between Norway and, if you listen to the last episode on mining, Mauritania, is Norway has a very strong quinary sector which supports its oil industry in case of errors or potential collapse, so that the country may continue to function without oil exports. The other aspect is Norway's petroleum exports don't rely on a single chain of production in which if one thing goes wrong, then the whole thing essentially will collapse. It's much more of a web. For further understanding this reference, listen to episode 3 on mining to understand why if Mauritania's iron mining industry collapses, the country probably fails significantly. This does not mean if the petroleum industry disappeared in Norway, it would not suffer, and one could theorize how far its Human Development Index may fall. Now, if the oil industry did disappear in Norway, it would not only affect the country, but most of Europe and subsequently the rest of the world, though mostly the developed world. Norway produces about 2.5% of the world's petroleum, and is the only energy-independent Nordic country out of Sweden, Finland, Denmark, and Iceland. If we take all of the energy Europe produces, which I will be doing a vast series on energy in the future, so don't worry about that. But all of the energy Europe produces and equate it to the energy oil can produce. So all wind and hydroelectric and coal and nuclear and whatever else, and you take all the wattage of energy that all of those sources produce, and then you equate it to how much energy oil can produce, then the Nordic countries produce almost half, somewhere between 45 and 50% of the energy in Europe. Norway produces 75% of that 50%. And as I said, Norway is energy independent, meaning they export more sources of primary energy than they import. 6 times the amount they consume, actually. It should be noted that I am just talking about primary production since I just mentioned it. I'll explain it fully in a future episode, but just think of it as the normal ways you would think of electricity being generated, like the sources I listed. These figures continue to grow in favor of Norway's petroleum production and energy independence, and more harshly for the dependence of the EU and Nordic countries on Norway for energy production. To tie it back, this would cause catastrophe for most of Europe, not just Norway, if the petroleum industry failed. To put this into further perspective, the EU represents about 1/6 of the global economy, with Germany, France, and Italy alone producing over half in terms of nominal GDP. Germany has the largest economy, go figure, right, and imports about 13 times the number of barrels of petroleum that it exports. Sure, the EU and Germany don't import all of their crude oil just from Norway, but you can be sure the cost of petroleum products would increase significantly if Norway no longer supplied oil. Beneficially, however, Norway is a very highly developed country, and its vast quaternary and especially quinary sectors support its petroleum industry so as to not result in the failure of the industry. For example, the Norwegian government, which is the quinary sector, produces a pension fund from a portion of the export revenue of Norway's petroleum. This fund is used for welfare programs and to support the Norwegian people because of the rapid fluctuations in the price of oil. Say the price of oil drops down from its current 60-ish dollars a barrel to around $20, like what happened in April of 2020. Yes, this would affect Norway's and the global economy significantly, as it did then, but Norway's government pension fund would mitigate a lot of the damage caused to the Norwegian people due to making far less money from their primary export. To bring up Mauritania again, nothing like this exists from Mauritania's iron mining industry, and its people would be affected far more heavily if the iron mining industry failed. Using that as a segue to move into a less developed but still developing petroleum industry, we can take a look at Iran. Iran is a large country in the Middle East, or more accurately, West Asia, with the Caspian Sea to the north and the Gulf of Oman to the south. Iran is currently the 7th largest producer of petroleum, while Norway was number 11. The country produces a little more than 4 million barrels a day and exports around a third of that. Currently, Iran is in a theoretically good spot with petroleum exports, since the largest importer of Iranian petroleum is China. Oil production in terms of energy was the highest in Iran before its revolution in 1979 and subsequent nationalization of its oil industry. Production fell off a cliff post-revolution and has been steadily increasing, but has never reached pre-revolution levels. However, Iran controls its oil industry now, as pre-revolution the country did not control its oil production and exports. Recently, Iran is experiencing a decline in oil production, theorized to be due to global sanctions. This is, of course, not good for the country, since from 1979 to 2012, Iran was experiencing only upward growth in its own oil industry. Iran actually was the most sanctioned country in the world until after the Russian invasion of Ukraine in 2022 put Russia as the most sanctioned. A sanction, or an embargo, is a penalty applied from one state to another state in order to financially coerce the sanctioned state to do something the state that decreed the sanction wants it to do. It's basically a political tactic used mostly by developed nations to financially force a less developed nation to do something it wants. In terms of Iranian petroleum, the United States began sanctioning after the Iranian Revolution in 1979 because of claims the country supported terrorism. The United Kingdom and the United Nations sanctions followed, but the petroleum industry continued to grow in Iran. It wasn't until 2012 that the petroleum production started falling rather rapidly due to harsher sanctions applied by the US and the UN because of nuclear weapons scares. The claims basically are that Iran began a rapid development of uranium enrichment programs, and Western nations were afraid that they were making nuclear weapons. These sanctions were lifted, the heaviest ones, in 2016, but the country is still heavily sanctioned overall and cannot seem to recover in terms of petroleum production. Regardless, the industry is still a large part of Iran's economy, about the same 17% Norway had of the country's GDP. Iran also produces more oil and has an estimated 15% of the OPEC's reserves. An interesting thought experiment then is to wonder why Iran is vastly underdeveloped compared to Norway. Since a lot of this discussion will delve into exploration of the quaternary and most importantly the quinary sectors, as well as several different theories that affect development of a nation, politics and whatnot. I won't go too far into this, but a couple of interesting points include the international sanctions I talked about earlier, as well as the country only having 45 years of its own sovereignty. Iran relies heavily on the export of petroleum, and I would theorize the sanctions placed on the country have had a widely significant effect on keeping the country down in terms of development. Taking a look at Norway, there are currently no international sanctions placed against the country, and Norway is actually a country that places sanctions on other countries regularly, including Russia and Israel. Another reason Iran could be suffering in terms of underdevelopment is, at least compared to Norway, is the centrally planned economy the country uses, which means the economy is managed directly by the government. The largest and arguably most important case study for this argument that centrally planned economies do not function over long periods of time and slow or halt the development of a country is the Soviet Union. Not something to talk about in this episode, as it would take far too long, but if you're interested, before I do future episodes on studies of economic development, then finding the studies about the Soviet Union's economic collapse due in part to a centrally planned economy is rather trivial, though if you've never researched economics before, you perhaps wouldn't quite know what to look for. And so my email is always open in case you're curious. Anyway, let's conclude by talking about Iran with a few facts about its petroleum industry. As I already said, the percentage of share the oil industry has in Iran's GDP is about 17% currently, which is a figure of about 57 billion. The country has a population of about 92.5 million people, which is quite a lot, but I couldn't find any figure in my research for how many of its employed population work directly in the petroleum industry. I would wager it's more than the estimated 210,000 out of Norway's 5.6 million total population. However, the percentage of the total working population is almost assuredly lower, since about 7.5% of Norway's working population is in the petroleum industry. That would be almost 2 million of Iran's people working in petroleum at those same figures, which is an astronomical amount considering the country only produces about double the amount of oil Norway does. We could assume there is a higher percentage, though, due to less advanced infrastructure in Iran because the country is less developed than Norway, and therefore almost assuredly has less developed quaternary and quinary sectors. But I would wager it doesn't account for almost 10 times the amount of people working in Iran's petroleum industry. We can also assume the numbers for accurate representation of workers in Iran's petroleum industry don't exist because of the underdeveloped quinary sector the country most likely has compared to Norway. Another factor potentially influencing the number of people working in the petroleum industry in Iran is the fact that the country has an estimated 2.5 to 3% of its population unemployed, while Norway has below 2%, I think it's like 1.7%, which are figures representing 2.5 million people and 96,000 people, respectively. Moving on to Nigeria, which is a large country in Western Africa that sits north of the Gulf of Guinea, which is the Gulf on that sort of curved part of West Africa. It is one of the largest countries in the world population-wise, with 236.7 million people. It is also one of the world's most underdeveloped nations, with a per capita nominal income of about $800 and a Human Development Index of 0.560. Nigeria is the largest producer of petroleum in Africa and has oil that is rather highly sought after since it is sweet, which means it's lower in sulfur content, and has mostly lighter oil reserves, meaning it is mostly used for the production of gasoline and other fuels. This is obviously important for developed nations that consume a lot of gasoline, such as the United States, which imports about 150,000 barrels a day from Nigeria, making it the 9th largest exporter of oil to the United States. For reference, the United States uses about 19 million barrels of oil a day, meaning Nigeria produces about 1% of the oil used in the US. Again, though, for reference, Canada, as its neighbor, produces about 4 million barrels a day for the United States, making it the largest exporter to the United States. Anyway, do you remember when I was talking about Norway and how an enormous percentage of their economy relies on the export of petroleum? And if the petroleum industry failed, even while it's unlikely the country would suffer enormous consequences, but because it is so highly developed, it would probably not fail as a state, and how the situation was more exacerbated in Iran because even though a similar portion of the economy relies on oil, the country is less developed than Norway. Well, I'm glad you remember that, hopefully, because the petroleum industry in Nigeria is basically the country's entire economy. Not 17% of its GDP, not 40% of its exports, but over 80% of its exports come from oil, with some years and figures I read about estimating up to 98% of all of the country's export revenue. The country has a 2025 nominal GDP of 188.27 billion, with some estimates saying around 14% of the total GDP comes from oil exports. The big problem with these numbers is we just do not know the truth. For example, the World Bank has not recorded a percentage of GDP due to the export of goods and services in Nigeria since the year 1960, while almost every country in the world has a recorded percentage from 2023. Why is this, you may ask, since the second oldest recorded percentage is from 2004 from Papua New Guinea? How could the World Bank, one of the largest and most sophisticated organizations in the world, just not know anything about Nigerian economics when it knows the economics of 99% of the world's countries? Well, it does know quite a bit, actually, but for some reason I can't find it. It doesn't know how much of Nigeria's GDP comes from exports. Couldn't find a really accurate number on that at all because I think most of the numbers come from the World Bank numbers. Anyway, the World Bank produces a specific report, in fact, known as the Nigeria Development Update. And I would argue the World Bank finds Nigeria specifically important because it is, along with Pakistan, the largest and most undeveloped country in the world. I assume, as I wonder it myself, the World Bank wonders what would be causing a country with such a large population and vast reserves of natural resources to become so undeveloped. In fact, Nigeria should theoretically be by far the wealthiest country in Africa because of its oil reserves, which are the 10th largest in the world. The wealthiest country, in fact, is South Africa, which produces a measly 100,000 barrels of oil a day compared to Nigeria's 1.6 million. Also, South Africa has a per capita income of about $6,400, while, again, Nigeria has about $800 per capita. That is less than half of the average $1,900 per capita income of the whole continent, while South Africa has about 3 times that. In fact, even when you compare Nigeria to Pakistan, the other very large and very underdeveloped country in the whole world, Pakistan has a per capita income of $1,600, and it is also less developed than Nigeria and has a larger population. So, why is all this? We always hear how the oil-producing countries are some of the wealthiest and most developed countries in the world, and in fact, we looked at Norway earlier for just that. And in terms of the Human Development Index, the United Arab Emirates, which is the 8th largest producer of oil, while Nigeria is the 16th, has moved up an incredible 27 ranks in the Human Development Index in the last 15 years. No other country even comes close to moving that fast. And in addition, the UAE is the 21st wealthiest country in the world by per capita income, while Nigeria is the 176th. That makes Nigeria the 17th poorest country in the world based on how much each person makes a year. Yet its oil reserves account for an estimated $3 trillion based on current oil prices. There are most assuredly dozens of reasons and theories for why this is all the case for Nigeria. But in terms of this discussion, I would argue it is the country's absolute dependence on oil exports. A larger portion of Nigeria's GDP is accounted for by agriculture, but almost all of it is subsistence, which means it is not sold for export. Nigeria also has enormous valuable mineral deposits which are hardly exploited. I think they produced I can't remember the exact number. I didn't write it down. I think it was like 6 metric tons of gold or something, like an absolutely tiny number. But they have these enormous mineral deposits. And again, more than 80% of all of the export revenue in Nigeria, the export revenue that Nigeria creates, comes from petroleum. But I think that's enough on countries. Let's move on and touch on fracking for a bit. Fracking is sort of a colloquial shorthand for hydraulic fracturing, which is a technique that cracks the walls of a reservoir using mostly high pressure water. This is the most common form of stimulating a well so that oil may flow more freely. And the two forms of fracking are known as unconventional methods of recovery because the aim of fracking is to permanently change the permeability of the reservoir. While the other three forms, which we talked about earlier, the primary, secondary, and enhanced, are just there to exploit the reservoir in its natural state. Hydraulic fracking is probably what most people are going to think of when fracking is brought up, but acid fracking is the other form, in which acid is injected to crack the walls of the reservoir instead of high pressure water. The reason fracking is so controversial is because of the environmental and health risks the practice poses. The main concern is fracking fluid leaching into water supplies, in which they then become contaminated. You might be thinking, well, I can understand acid fracking for that, but hydraulic is just water, right? Well, no, the fluid is mostly water, but it contains either sand or aluminum oxide, which are particulates mixed into the hydraulic fluid to hold the cracks that form open. This is what the concern is because aluminum especially is highly toxic to humans and most animal life. Other risks include air pollution, high water consumption because high pressure water uses a lot more than conventional water injection methods, risk of earthquakes due to changes in bedrock formation, and noise pollution. The reason air pollution is a risk is because either oil sands or shale deposits are exploited in fracking methods most often, and the greenhouse gases emitted from these deposits hang around in the atmosphere far longer than the petroleum gases from common conventional liquid petroleum reservoirs. Shale oil is rock fragments in which liquid petroleum can be derived through various chemical processes, and oil sands are fine particulate materials such as sand that become soaked in liquid petroleum. Fracking is most commonly practiced in the United States. It's mostly practiced in the United States, mostly in North Dakota and Texas. And it is the main reason the United States has become the largest oil producer in the world. Though many other countries have banned fracking as a practice due to concerns over the risks. I think that is enough on petroleum for now, especially since we will be delving heavily into petroleum chemistry, processing, and economics in the future. So let's briefly touch on natural gas, since this episode is getting rather long, I think. Natural gas is mostly comprised of methane, which is the simplest hydrocarbon. It is, of course, a gas instead of a liquid like petroleum, but commonly exists in reservoirs alongside petroleum. Usually, natural gas that is captured from a reservoir is cooled down to a liquid state for ease of transport. You may have heard of liquefied natural gas, or LNG, before. Natural gas is either associated, which means it exists in petroleum deposit reservoirs, or non-associated, meaning it exists by itself in natural gas fields. Natural gas, or just gas, used in your home for cooking or heating is just methane gas, as all of the other gases that exist in the mixture of natural gas are removed in processing prior to it being sold and used. It is not really known which country has the largest natural gas reserves, as it is a gas and less permanent than liquid petroleum, and new reserves are discovered all the time because of, well, the nature of a gas and how it doesn't stick around for too long. Russia, Iran, and Norway do contain some of the largest reserves, however, and are also the largest producers. natural gas is measured in cubic feet or cubic meters. Global demand for natural gas continues to increase, which, alongside the increasing demand for oil, has proven to mostly be a boon to oil producing countries, since most of the largest oil producing countries are also the largest natural gas producing countries. Go figure. Natural gas itself isn't a big concern environmentally because even though methane is actually a larger potential risk as a greenhouse gas than carbon dioxide, it has a higher radiative heating, which is a separate term, which basically means its warming effect on the Earth. Methane doesn't hang around nearly as long in the atmosphere as carbon dioxide. Also, methane is converted into carbon dioxide when it is burned, which is carbon dioxide and water vapor when it's burned, which is what the vast majority of natural gas that is produced is used for, is burning for energy generation. Regardless, natural gas is still the second most concerning greenhouse gas behind carbon dioxide due to its warming effect, its radiative heating, and is about a third of the contributing greenhouse gas to anthropogenic global warming, which is the warming of the Earth caused by human activity, which is mostly industrial activity. Alright, that is quite enough, I believe, for a foundation in quarrying petroleum and gas. That also concludes this series on an introduction to global primary sector industries. The next episodes will most likely be foundations and explorations into the Human Development Index, other versions of other theories of countries' development, macroeconomics, the history of industrialization, and more to set us up for exploring secondary sector industries. Hopefully that all sounds interesting to you. And if you enjoyed this episode, feel free to send me an email at fabricofindustry@gmail.com. Or if you have any comments or questions or suggestions, please email me as well. I'd love to hear from any listener. If you would like more direct communication, I have a Discord server as well. Leaving a positive review for the podcast on whichever aggregator you use, be it Spotify or Apple or something else, is a huge boon to me and helps spread the podcast to more people. Liking the Facebook page as well, which you can find by searching Fabric of Industry, helps spread the word. As always, I hope you enjoyed, and I will talk to you next time.